Hey guys, it's Andy here. I've been doing a lot of reading and watching YouTube videos and reacquainting myself with some electronic theory that I had forgotten about, and I now understand where I went wrong. This device right here, it has these heat sinks. These heat sinks are hooked up to linear converters. They look like MOSFETs almost. It's just, alright, you see them there? Right on the heatsink. Boom, 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 boom. Those are linear. That's why it's heating up so much. It's down converting 70 volts to the 35 and the other respective 6 volts and 9 up, 9 down. So that's why they get so hot. Why the heat sinks are live, I don't know, but it doesn't matter. So I now understand what's going on here, and this is the wrong device. What I should have been doing was this, which I had done back 10 years ago in college, I guess. This is actually from my first, is it getting warm? It's all wired in, but I tested it. I won't get electrocuted this time. So this is a transformer. Okay, I did this in college. I made my own variable power supply, really cheap one, using this guy. This converts 120 volts AC to, it says 24, but it's actually 28, almost 29 volts AC. And then if I put it through a rectifier, I have to buy a better one, a 100 amp one, just to be safe. I'm pretty sure this is a really shitty rectifier. I used to have a whole bunch of them. I can't find them. Don't know what happened to them. But it's a full wave rectifier. So if you want to charge your Powerwall using grid tie, all you need to do is find a transformer that transforms 120 volts to 24 volts, and then you put it through a rectifier, and that actually increases the voltage. So you have almost 35 volts AC or DC coming off that, and then you just I guess you could put a smoothing capacitor. So I'm gonna hook this thing up to my oscilloscope that I've got there, and I'll see how dirty the input is, because it might just be able to be handled by this solar charge controller just fine. I think this thing is like a buck converter. Anyways, these pulse width modulator guys, they I think they're like just really, the cheap ones are just really shitty buck converters, or whatever, more high quality buck converters than just a simple buck converter, but whatever, it doesn't matter. But so anyways, this thing, I'm done with it. I won't use it anymore because it's too dangerous. This thing, I'll have to find out what its maximum output amperage is at, it'll be like 35 volts DC-ish. So it'll be doing better than this guy, and all it is a transformer. So if you can find a transformer that has 120 volts in, 24 volts out, then buy, I'll put links once I get the thing built. It sucks because I have a bunch of them up north at my parents' place of really high quality full wave rectifiers. So now I gotta buy more because it's too far to go up there again, but whatever. So anyways, put through a rectifier. Then if you really want, you can put through a capacitor and maybe something else. I don't know. I was seeing capacitor and a diode, or a capacitor and a resistor to help smooth it out. And I don't know. I don't think we really need that because of the it's going to be figured out through this guy, but I might do it. I have the parts. So anyways, I just wanted to make this video and just make it clear. This thing is wired up. I'll show you the output voltage. So it's 120 in. I'm just take my word for it. I'm not gonna waste time with obvious. So it was broken too. I had to fix it. I should show you. Yeah, see, 28.3 volts AC is coming out. AC, not DC, right? AC. So you need a full wave rectifier, not a half wave rectifier. You have to get a full wave rectifier that comes off this, and then you'll get an even higher voltage. I think it's like times 1.6 or or something like that is how much more voltage you get. And then it goes into here, and this guy can handle it, clean it up, drop it down, and put it into the battery pack at 29.4. Or, you know, it safely charges it up based off the battery voltage, so that's fine. So this is live right now, I just have it hooked up. But yeah, I had to take it out. That's why there's this, because I had to use a drill and pop off these rivets that were holding it together, take it apart, and then I had to remove, where is it? This guy here. I couldn't figure out what this guy does. I don't think he's a Zener diode, but he probably is. It's possible that he's a Zener diode, because I'm trying to see what it is. I'll just read it off. Okay, so it says 250 volts, YM, 115 degrees Celsius, PSE jet, J-E-T, 250 volts, 1 amp, that's weird. So this thing's like a limiter, but anyways, it broke. It's very tiny, very, very tiny. So that was in there, and it was on the 120 volt side that this thing was placed. So I don't know. If someone knows what this part is, let me know. 1 amp, 250 volts, 115 degrees. It says jet on it. It says in brackets PS and then E jet. You can read that. So yeah, if you know what that part is, let me know. But anyways, that's where I've been going wrong. It's not waste. I learned a lot, right? I learned a lot more. I might just get a buck converter, because I want to down the voltage from like right now it's at 28 AC. It's going to be shot up by some kind of factor in order to while I'm full wave rectifying it to be DC voltage, so that's fine. And then I think I'm gonna buy a buck converter to test out. I think I'm gonna do a hybrid of a buck boost converter so that I can use it later, because I doubt once I have the full wave rectifier and this thing running, I think all I need to do is connect to this, and I might need just a smoothing capacitor at most, like connected between those two leads there. So then I think that's all I need, and then that reduces the cost even more, because this was like 35 bucks, and like this was free, but I'm sure I can get more of them for a decent price. And full wave rectifier 100 amp ones, they're very cheap from eBay, so it's not a big deal. So anyways, yeah, so if you're trying to charge up your Powerwall, just buy one of these. Look at my previous videos to see which one it is, because this one is really good, and there's a lot of ones that look identical to it that are complete garbage. Just buy this, find a 120 to 24 volt transformer, this size-ish or bigger. It has to be pretty big, because you want to be able to push at least 6 amps or more, because this thing could push 6 amps through the solar charge controller. So get a pretty good transformer, and then get a 100 amp full wave rectifier, like a big beefy one, because you want something that lasts forever, right? You don't want to be messing around with weak ones that heat up. That's too risky. Get big fat ones so you're safe, because you're charging off the grid, so you don't care about wastages. You don't have to be super efficient with this stuff. You just have to make it work. So yeah, that's all you need, and then goes to there, and so we don't need this death trap anymore, which is really good news. So anyways, let me know what you think. Watch my previous videos to understand this other stuff. Look into buck converters and boost converters and transformers and full wave rectifiers if you're interested in this stuff, so you can get a better understanding. And if you're looking at doing this to charge up your Powerwall, because I don't plan on doing solar or wind for quite a long time. I want to build these first and then do that. So anyways, let me know what you think. Please comment, like, subscribe. Have a good day.